Now we are at page 8. Okay, now you know the XY plane. This is X, this is Y. The vector is a line segment, straight line, has a beginning at point A, for example, and an end point at B, for example, and the direction. This is the vector AB, from A to B. It is a different vector than from B to A. It is the negative one. We see that. Or we saw that. To deal with vectors with the XY plane, maybe sometimes we have this vector. You can name this vector as you like. I name it here A. I am free to move this vector anywhere I want. Just I need to keep its length and its direction. This is my vector. I cannot draw it like this. This is not A. This is A. This is not A. I can move it to A. I need to keep just its length and its direction. So the XY plane, maybe sometimes I ask you a question or you see an example, you will see different vectors in different places. You can move them anywhere you want. But keep the direction, keep the length. So if I need to study this vector with the XY plane, I need to move it to the origin. And this is the beginning point. I need to move it here. So this is my vector A. Tell me if I am wrong. Okay. This is A. Any question about this? Nothing. Now each vector. Assume each vector has a length or magnitude. This length, assume yourself, you can walk from point, the origin, to this point, let me name it P. You can walk from O to P. You have you are free to choose your way. Some of us maybe will move directly like this. 5 steps and I reach from O to P. Another one may tell us I need to go like this. 1, 2, 3. 1, 2, 3, 4. This is 3. This is 4. Here I have 5. The Pythagorean theorem, if I have a right triangle, I have some values. If I use this 3, this is 4. Assume this is R. I need to find R. R squared is equal to 4 squared plus 3 squared. You know that. But that means it is equal to 16 plus 9, which is 25. This is equal to R squared. What is R? This is square root of 25, which is 5. So this is my length, 5. In this example, different example, different values. Now, again, the first person go directly from O to P, 5 steps. But he walked 5 steps with an angle, with a direction. This direction, we name it theta. Theta from the horizontal, which is X direction. Another note to deal with the XY plane. This is positive X, you know that. This is negative X. This is positive Y. This is negative Y. We have another name. We name this is east on map on the ground. This is west. This is north. This is south. When you see any question talk about east, west, it is like this. Also, this is right. This is left. This is up. This is down. In 2 dimensions we are talking about. Okay, 2 dimensions. But if we have 3 dimensions, if we have the z direction, then we have the upward and downward are the z's. And you can assume your direction as you like. It's your question and your pen and your hand. Okay, and your mind. Now, if that person, the first one, taught us, I walk 5 steps to the northeast. You can't tell us that, right? Or east to the north. In this direction. It is right, but this is not a scientific speech or not a scientific information. You need to give me the direction, exactly. Because of that, you need to give me the angle, theta. So if we have this angle theta from the x, positive x, we have another angle phi, for example, from the positive y. You need to tell me, I move 5 steps direction of theta from the x, positive x, or phi from theta, maybe it is 30 degrees. Phi will be in this case 60, right? It is 90 minus 30. The other person who move in this direction, this is 4, for example, and this is 3. This is the point B. This is our vector. When he moved in x direction, he moved 4 steps. These 4 steps in x direction. We can name it the vector length in x direction. And this is the 3 steps in y. So the vector A is equal to, as a vector, 5 steps or 5 meters. It's a line in theta direction from x direction. Okay? Can you understand this? It is 5 meters from theta. But here, A is equal to 4 steps in x direction plus 3 steps in y direction. It is the same way. It is the same point. Now, using A, I can reach P from the origin. Okay? Now, the theta, the angle theta, how can I find it? I'm in the future, we will not use this one. We can find it. We will find it in our example, but we will not use it. We will use this representation, but with a different, we'll change something. We will not put x, y like this. We will put I, K, J, K as a unit vectors. So we'll use it like this. It is more simple and more organized. Now the angle theta. We can find theta by using this. Tan theta is equal to the y component over the x component. Right? Sine theta. We have also cosine theta. We have this angle theta. This is the opposite. This is the adjacent. This is the, what is the name of this? The vector length A, or I can, hypotenuse or something like that. I'm not good at names. Okay. This length, which is 5, it is A, the vector A. It is the length of A. So I will put it here. Length of A as a vector, we can write it like this. We need to put these lines just like that. Absolutely. This is the length of A. Now we know that our vector A length, how much is it? It is 5 meters. Because we assume that, because this is 4, this is the 3, so this is 5. Using the Pythagorean theorem, we just solved it. Sine theta for the right triangle. This is theta. This is the opposite. This is the adjacent. This is the hypotenuse. Yes. Now, tan theta is the opposite over the adjacent. This is y over x. Sin theta. Sin, it is the opposite over this. This is the opposite, or I can name it y. This is the opposite, which is y, over the length of A. Cosine theta, it is the adjacent, which is x over the length of A. This is the length of A. It is the same theta. I can solve it now. If you like to put y is 3 over 4. Tan theta is equal to 0.75. Now, y is equal to 3. A is equal to 5. Sin theta is equal to this over this, it will be 0.6. There's no units for sin. Cosine theta, it is x, which is 4, over A, which is 5. 4 over 5 is 0.8. Now we have sin tan theta 0.75. I will finish this now. Sin theta is 0.6, cosine theta is 0.8. I will find out theta. In the 3 cases, theta is the same. Okay. I will use cosine theta, cosine inverse. So I will solve it here. From here, I need to find. We sometimes write it A tan or tan inverse of this numerical value, or 0.75. Tan inverse to 0.75. It is equal to 36.87 with approximation degree. What about the sine? I will put sine inverse to 0.6. Sine inverse to 0.6. It is equal to 36.87 degrees. Now, tan, not tan, cosine inverse to 0.8 is equal to, let's see. It's the same angle. You can use any formula of them to find the angle, but if you know just the x and y, you directly use the tan. This is page 8. We need to finish. We will be fast here. It's okay. Page 13. And we will start the next lecture next time. Any question? Any question online? Yesterday, we talked about vectors, that it is important to deal with vectors. We can deal with a vector from between 2 points, from A to B, in a free space. Okay? But it is common to see vectors on the XY plane. We know that this is the X direction, positive X, and this is the Y. And we talked also about the X means that to the right or to the east. Y is the same as to the north or upward. Okay. Now we'll deal with some vectors. I'll try to draw all that plane with positive and negative parts. Maybe we will use them. This is positive X, this is positive Y. And we assume that we have a vector. And we name that vector as A. This vector, we represent the vector by putting an arrow on the top of that vector or by writing it with a bold font. But using Blackboard, it's okay by using arrows. If you need to use the computer, it's okay to, if you can, or you know how to use equations, applications, you can use the upper arrow. But if you don't have it, you can simply use the bold font that we know that's the vector. Now, also yesterday we talked that each vector has a magnitude or length. For our vector A, its length is A between the absolute value. So this is the magnitude of A. It is just a number with a unit. Maybe if this vector is a displacement, the unit is a meter. If this vector is a force, the unit is Newton. If this vector is a velocity, it's meter per second. We will see that, and by using solving examples, we know more. Not all of our vectors are horizontally or vertically direct. Okay, they have an angle from the positive X. We can name it. You are free. I will name it theta. Theta. Or we have another angle from the Y direction or the north direction. You are free also. We can name it phi. Phi. Okay? It's the same. Now, for each vector, it has components. We said from yesterday that we can walk along that vector with the direction of theta. It is north-east direction, but it is not scientific talk to say northeast. It is just a vector length with theta direction. So if you need to tell me your vector, you need to tell me its length and its direction. Or theta, which is theta. If you told me that your vector is equal to 6 units in length, okay, and theta is equal to, for example, 35 degrees, then I can go from point A to point B by your information, which is the length and the direction. There is another way. If you told me I can walk, for example, 5 steps to the right or to the positive X direction, then I walk to the north or to the positive Y direction 3 steps. So it is simple. I can walk in this direction to the positive X, maybe 4 steps or 4 minutes. Then I turn my direction with 90 degrees to the positive y, and I walk, for example, 3 units to the positive y. So I can reach from A to B by using this information. So you told me your vector A is 4 units in x direction plus 3 units in y direction. It is full information. So you have two ways. Either you told me the length and the direction, or give me the components. For example, you know that 6 is equal to 3 multiplied by 2. If you told me my quantity is 6 or my quantity is 3 multiplied by 2, it is the same information. You give me the components of 6, right? Here it's the same thing. You give me the component of the vector A in 2 dimensions. In 2 dimensions, but our life, you know that we live in 3 dimensions. For example, this is x, this is y, and where is the stick? Yes. And this is z. X, y, z. Yes, this is z. Right? It is going out from the board. But we need to, if we like to draw it, sometimes we draw it like this. So this is 3 dimension, but this we can imagine it. I will talk about it later, but we will not deal with it too much. Okay? Any question about this one? We have 2 ways to tell about vectors, length and direction, or the components. From the components, I can know the direction. Because yesterday we talked about the trigonometry relation, which is tan, sine, or cosine. This is y, this is x, and this is my xy plane. There is no difference in color, right? This is useful for us here. Now, this is my theta. Can we find theta? The answer is yes. Because tan inverse of theta or tan theta. Let us talk about tan theta. It is the y component over x component, which is the 3 over 4. Yesterday we solved it and we found the theta as 35 degrees, I think, or something like that. So we need to use tan inverse or theta. What is theta? If you take tan inverse for both sides, take for this tan inverse, give me this, okay? Tan inverse for tan, and take also tan inverse for this. This is the same. Tan inverse will cancel tan. This is the way, man. Okay? You can do it directly in your calculator. This is theta because we cancel tan. This is theta. This is tan inverse to y over x. You can't find it. And again, be careful when you use your calculator. A good way to train now. Before later, you have 2 systems, radians and degrees, and we will talk about it. Don't worry about it. Okay. Okay, now I'll start to solve how to find the x and y components. I'm on page 9 now. What if I have a vector? I'm in page 9. I have this vector. And the name of the vector is R. And the y component of the r is 5. And the x component is 7. I name them Rx and Ry. It's logical to name it like this because we have X and Y. Be careful, we are now talking about math. We don't have anything physics. In the future, when we talk about physics, the X component will cover the time. Here will cover the velocity, for example, or something like that. Now we are talking about math. Okay, what if I ask you, what is the length of R? Can we find it? How? We need to use what? Yes, this and Pythagorean theorem, which is r x squared plus r y squared. If we need it squared, if we don't need the square, we need that square root is equal to 7 squared plus 5 squared. Yes. It will be equal to 8.6 something. Unit of length. Maybe it is not, maybe it is force. So I put now, these days, I just use units. But in the future, I don't know, it's a length or something like that. Okay, what is theta? I can find theta in 3 ways. I can use sine and I can use that theta is equal to tan inverse of Ry over Rx. Or it is equal also to sine inverse, just like the previous time, which is the hypotenuse. What is the name of this one? Which is the length of R, which is 8.6. It is the length of R over the opposite, which is Ry. Or it is equal also to cosine inverse to the length of R over Rx. All of them will give me the same theta, which is 35.53 degrees. Any question about this point? We just have a vector. We know about its components. The components is Rx and Ry. Because the vector name is R, so it has an Rx and Ry. If the vector is B, then it is Bx, By. That's all. What if we have the same example but in a different way? What if we have this example? We still now on page number 9. We have a vector, and this vector now is F, which is a force, with units Newton. F length is equal to 316 newtons. And we need to know theta, which is 35 degrees. I am now telling you what is the components for X and Y. I'll tell you something. The components, as they told me when I was in the school. If we bring a light from here, then we will see the shadow of the vector here. If we put the light aboard, then we will see the shadow of the vector here. Or if we drop anything from the end of the vector to the X direction, then we will see the X component of that vector. If we drop anything from the vector to the Y direction, then we will find the Y component of that vector. And also if we have Z direction, we can find the FC. Okay, we have the theta. Can anybody tell me how much phi is? Who can tell me how much phi? I will put the What's the name of this? The chat is. The chat is here. Also online, you can answer that, even by your voice, or you can write an answer. How much phi? Yes.
Oh, you're asking for the angle?
Yes, this.
It's 55.
I'm not good in calculations, but when we add them, they are 90, right? Yes, 55. This is the angle to complete the right degree, which is 90 degrees. Yes. Okay. Now, what do you expect I'll ask you about? Now I give you the length and the angle, the direction. You can find the components fx and fy. Fx from math, it is equal to the length of f cosine theta. Fy is equal to the length of f sine theta. Okay? This will give us the length, it is 316. Sine theta, sine 35 is something, sine 35. This will be equal to, it is given for you, it is 258.85. Also the same for this one, it is the length of f which is given 316. No cosine here, right? Here we have the sine. It is equal to 181.25. What is the unit? If the force F is by Newton, what is the force? What is the unit of its components?
Newton.
Should be Newton. Okay, so this is Newton. This is for more than one reason. The first one, the right hand should have the same units. Cosine doesn't have any unit or dimension, so they have the same. The other reason, when we talk that any vector has two components, you can assume that it like their sums. So the force plus force, this is the dimensionality. Okay, can we solve it in a different way? What if I didn't give you this one? You have 55. Who can tell me? I need now fx and fy again. It is the same. Fy, no, f, just f. The length of f and the length of f. We have important thing now. This is fx and I have phi. What I should use, cosine or sine? I am sorry if I use your answer as an example. Not just me, my colleagues and when I was in the university. They just assume the x component has a cosine. No, the cosine is in the direction of the angle. When we have the angle here, 35, we use the cosine for x because the angle is from that direction. Now we have the angle from y direction. Because of that, we use the cosine with the direction of our angle, of the given angle. The angle is given from x or from y. I'm asking now, the angle is given, phi here. Is it from x or from y? Now we need to use the cosine with y, because the angle from y. Okay, this is the point. Now fx, we need to use the sine of phi, which is 55. Here we need to use the cosine of 55. If you remember, cosine theta is equal to sine phi or 90. Let us 90 degrees minus theta. So cosine 35 is equal to sine 90 minus 35, which is 55. So we have the same value. Sine phi is equal to cosine theta. So we have the same X component, which is 258.85 newtons. Also here we have the same value. Do you think if we change the direction of our calculations, then we will change the nature? No, we cannot change the observables. We cannot change the component of the vector. They will still the same. But we just, from the first step here, we look from here. For the second step, we look from this direction, just like that. It is the same. Is it logical for you? Any question about that? Online? Ruin everything. What if I have, this is the vector. And Rx is 7 and minus 7, I'm sorry. Right? And this is positive 5. Let's do it. Come to solve it. He will put like this. Minus 7 squared plus 5 squared. This will be equal to minus 49 plus 25. And this will be equal to the square root of the minus something. Or it is not a negative. For example, if this is minus 5 and this is positive 7, like this. Minus 5 and this is positive 7. And we have this way. When I finish now, you will understand what I mean. Then you will find it is the square root of 24. And then you will find the square root, it will be something. This is wrong. Who can tell me why? Excuse me?
It's not negative 25.
Yes, it's not negative. Because the length is always positive. The negative sign in physics has a meaning. It is a direction. If you like to put the negative sign in your calculations, you have to do this step. Use the positive, and this is the negative 5. Positive, negative 5. And all of negative 5 is squared. You need to use the parentheses. When you square the minus sign, it will be positive. In this case, we have the right answer, which is 4. 74. Is it like that? Something like that. It is the right answer. 6. Yes, you're right. 74. This is the right answer. It's not 24 because we are not tricked by the minus sign. Anytime you will you think yourself confused with the signs, just use the parentheses. It is the programming. If you know from computer science, you use always parentheses. It is always useful word here. Okay. Any question about that?